So hello friends of Euler's Toolbox, let's play FizzBuzz. Well, that is a programming exercise. The trick is to do the following. Every third time you have to say fizz, and every fifth time you have to say buzz. That's then comes a fizz. So we are 5, 6, 7. We say 7, 8, we say 8, 9, we say fizz again, 10, we say buzz again because it is divisible by 5, 11, 12, we say fizz, 13, 14, and for 15, we say FizzBuzz, which is the problem. Generates the most important problem, so we have to say FizzBuzz. Well, the first attempt that everybody uses would be ifs, so a sort of castled ifs. So let's try that. The function we call FizzBuzz, and we want to run that to n, and we make a loop. For k equals 1 to n, we just simply try k for the moment and say end, and run that to 20. Well, now we want to exit fizz if the function is divisible by 3. So we do the following. If mod k3 equals 0, you can also say if not mod k equals 3, then fizz, else, or k, and then end if. So that works. Well, this is the first thing. Now we want to enter buzz. So we develop a change, else if not mod 5, then k5 of course, then buzz. Yeah, works. Yeah, let's now get FizzBuzz. That's the case if it is divisible by 3 and also by 5. So we have here if not mod k5, then FizzBuzz. Yeah. Else fizz, end if, and we have to delete that. So let's see if that works, and it's easy enough to see that this is indeed correct. So fine. Well, that is one solution which is quickly done. It is by far not the best solution, and it's not expandable. That's the most important thing. For the first test, we just want to get rid of the loop, because we might have to use this function outside in another way. So we enter k here and just forget about the loop. So we delete that line, and we delete that line, and then instead of printing it, we return it from the function. And here we have to return not k, but the formatted number k. And now we have to write a loop on the command line. Let's do that. For k equals 1 to 20, FizzBuzz k printed end, which has just the same result. Okay, is that a good solution? Well, first of all, we have code which looks strange. So we have not mod k5 twice. which looks rather suspicious, doesn't it? Isn't there a better solution? And indeed there is. Let me show you. We start with function FizzBuzz k in the same way. And then we make the output, instead of assuming the output, instead of ifs and else if, we fabricate the output one after the other. So the output, first of all, is empty. And now, if the number is divisible by 3, then we append fizz. Now we can just say and if, surprisingly. If the number is divisible by 5, we append buzz and if. And if it's divisible by both, now we have FizzBuzz. Now we cannot just return S, because if it is neither the first nor the latter, we have to return the number. So we have to do an if S equals empty, then return, what was it, K, else return S and if. That looks very nice. So let's do that. We do the same loop as here and try it. Doesn't work. So why not? Yeah, because this is silly. We have to write S equals S. Now it works. Well, this is kind of modular programming, extreme programming, something like that. You test, and if it doesn't work in a simple example, you just expand it. Well, what if we want more? If we want some more functions, say we want also jazz in case it is divisible by 7. So how would we do that? How would we do that? Well, we want the same function, of course, and we can just add another line here. So new line, paste, and we make 7 and enter jazz. And now we have to go to, I think, 105. That's 7 times 3 times 5. Let's go to 120. So we have FizzBuzz jazz at 105, and if we have, for instance, at 7, 4, 5, 6, 7, we have jazz. At 14, we should have jazz 2, and so on. So that works. At that point, we become suspicious if we cannot make that more general. And we can, of course. We have to have a set of prime numbers, for instance, and a set of strings for the prime numbers. And we, instead of that, we make a loop. So how is that done? Let's make 4. Let's call that U or something. 1 to length P, length P, and then we insert that a little bit and say P, U. That's a check, and we use the second parameter to enter SP, U, and then remove that, and the rest is just the same. So we have to call that properly, and we do that in the following way. So Let's take the same loop, copy it here, and now we have to enter some more parameters. P, for instance, we take equal to 3, 5, 7, or we just enter the parameter 3, 5, 7, and then we take a string, a vector of strings, does the same. FizzBuzz at 120, and there we have 105. We should FizzBuzz jazz. Yeah, it's just the same. Okay, we have currently this solution here. To play our original FizzBuzz game, we can just use default parameters. So the default parameter for P would be 3, 5. And for the string would be the string FizzBuzz. This would still work, but if we just play FizzBuzz K, it also works now. Well, that's already very nice, but what if we want even more? Say we play the game with 2 and 4, and the strings fizz and buzz. Yeah, now we get fizz at every second number and also fizz buzz at every fourth number. But we actually don't want that. If in the case 4 we want only buzz, say. So how do we fix that? Well, we want to skip 2 and not to enter fizz if the number is divisible by 4. So first of all, we replace the order here. That's at least the solution I came up with. And now we have buzz fizz at 4, but we don't want to have the fizz. So what we enter is another skip value. So in case the first parameter applies, we want to skip 1. In the second case, we don't want to skip. Yeah, we need only 3 parameters, so we have to modify our function a little bit. The skip values we call as k, and the default for FizzBuzz is 0, 0. So that still doesn't work because I haven't programmed the skipping. In case our first parameter applies, in this case, we have to apply the skip. So let's try u equals u plus skip u. Works. So we modify the parameter of the loop, which is possible in Euler's Toolbox for for loops. Yeah, this is the way this could be done. So let's enter something more, maybe go to 7 and enter jazz, which should skip nothing. And we get this fizz jazz, and I'm sure it will also work to 120 and 105. Should output buzz jazz. 56 should output buzz jazz because it's divisible by 4 and by 7. And another number that is divisible is 28. 28 is interesting. Gives buzz jazz. Now there's only one thing remaining, the default value. So this is very strange. Assume we have something like the original one, which was 3, 5, 7, and we want to skip nothing, and we can just enter 0 here, but we want to enter nothing at all. And that doesn't work because of this skip value is too short. So what we want to do is actually use 0 here, which still doesn't work, but we can use round brackets in Euler's toolbox. Like this. So SKU just means the use element of SK in case SK is a vector. If SK is just a number, it will return this number. Now that's a trick in Euler's toolbox. Otherwise we would have to use another if. For instance, if we have a vector 1 to 5, 1 to 5, then v4 will return 4, of course. But if we have a number, it will just return the number. So it works for vectors which are real numbers and also for real vectors. And that's why this default value sk equals 0 works in this case. So this is the last trick I want to show you in Euler's toolbox. Thank you for watching this video.